Hey everyone, today I want to show you guys some designs for vertical signal strength cues. So this first design that I have here is actually from a Reddit post, and I'll leave a link to the original post in the description. But to me, this first design, instead of behaving more like a cue, it behaves more like a shift register. So the way it works is you put a signal in to the top layer, and then as I hit this note block down here, it sends a signal to tell each cell to shift its data into the one below it. You can see here, I already have a signal in this guy. If I were to press this here, you'd see it shifts down to the next one. Press it again, it'll shift down to the next one, and so on. Now, the advantage of this, though, is that it can actually store the zero signal in between two other non-zero signals. So if, say, I put in this book, I originally put in signal 5. If I were to put in, say, signal 15, send it in, see, we have a 15 up here, a 0, and then a 5. And we can actually shift it too, and it'll stay in order, right? So now 0, 15, 0, 5. And if we keep shifting, each signal will just keep moving down until we have it outputted at the bottom. So the way that this first design actually transitions the signals from one cell to the next is when I come over here and hit this note block, the signal comes through, it triggers this repeater inside to reset the signal that's in the cell. So it clears this cell out, and then one redstone tick later, it will tell this repeater to unlock and read what's in the cell above it. And then there's also a torch tower here, so it cascades the signals in the correct timing up throughout all the cells. So the idea is that clear this cell, then read from the top one, clear this next cell, read from the one above it, clear the next cell, read from the one above it, and so on, all the way up for however many memory cells you have. The second design that I have here is a modified version that I made that's based off this first one, except it eliminates the need to create a pulse that shifts the signal cells. Instead, this one shifts the signals through the queue automatically. You can see when I come over here, say I want to put the signal 5 in, all I have to do is hit this note block. You see the signal travel down to the output automatically. Then, say I want to put the signal strength 10 in after that, signal strength 15 as well. You can see signal 5, 10, and 15. And we can change this output by hitting the note block down here to clear this bottom cell, and the signals above that will trickle down on their own. So now we have 10. See the 15 also shifted down. Do it again, and now we have 15. So the way that this works is I added this purple circuit here that detects when a signal strength is stored in a cell. And if a signal is stored in the cell, it will activate this purple line, which will disable the signal strength from being able to travel from the cell above to the one below it. So you can see here, if I add another signal strength, comes down, you can see that this line just turned on as this signal strength got trapped in this cell. And see now it locked this comparator, so now the next cell, the next signal strength we put in will get trapped in the one above it. And this red and orange line on this side is the reset line. So as I hit this reset button, it clears this cell. The signal above that cell is then allowed to travel through the blue line. As it travels through the blue line, it'll reset the cell that it just came from, and repeating the pattern up the memory cell tower. So you can see that these first two designs, they're very small and compact and elegant because we're able to send signal strength downward in a very compact fashion. You can see, if you take a look again at the blue line, we're able to make like a 180 turn and descend the signal in such a small space because of how redstone is able to be powered. Actually, I'll come over here, show it off a little better. You can see if we try to send a signal downward, we're able to power a block, which then powers this dust, which will then power this block, and then that bottom block can be read by another comparator, and the chain just continues downward, creating this nice one-to-one staircase downward. Let's see if I power it. The signal goes all the way down. We can take it a step further, and we can actually do, instead of a staircase down, like here, we can actually bend it around 180 degrees and actually zigzag the signal strength down instead, creating this 3x1 tower. If we try to send the signal upward, we can't take advantage of the fact that we can power a block above a dust. So what ends up happening is if we try to staircase the comparator strength, signal strength upward, we get this kind of wider staircase where it ascends at a much slower rate, you can see. What we can do is we can make a spiral like this, but it takes up much more space still, and we're still kind of ascending at a much slower rate than sending it downward. We can try adding a block in between and just seeing what's going on, and you see it doesn't help, right? It just widens the staircase even more, and it doesn't really help our situation. If we try to zigzag it like we did with that tower, well, let's see what happens. We actually run into a problem. Some of you might be able to see it already. So if I were to power from the bottom to send the signal up, what happens? And so I power it, and we try to turn it off, and wait. The signal is actually staying on, because what happens is we basically just made a feedback loop in comparators, or like another type of memory cell, right? So if we follow, this dust is powered, it powers this block, it's read by this comparator, it powers a block into dust, into another block, into a comparator, into this block, but wait a second, it powers this top dust and this bottom dust, creating a loop, the feedback loop. And this actually happens all the way up, however how you stack it. And so this upward zigzagging pattern can't work for us. And that brings me to this last design. So this last design behaves exactly like the second one, except instead of the signals traveling from the top and going to the bottom, this one takes the signals from the bottom and sends the signals upward. So if we take a closer look at what's going on here, you can see we have our comparator memory cell, and then coming around the back here, we have a dust that powers this blue block. It's read by the comparator, the signal travels up and around, and then back here into this block, which is the second memory cell. So let me actually put some signals in. So if we come over here, we're going to put in 5. There's no block. See the signal travels up and gets stored in the top. Then I'll stay signal strength 10. Say signal strength 15. Get a better view. See, we have the top 3 cells are occupied, and if we come over here, we see we have 5 in the first one. Clear it, then we should get 10, 15. It's empty. Once a signal is actually in the memory cell, you can see that this line would be powered. It powers this block. The signal travels through this comparator that the signal just came from below, powers this block into this dust, and then into this repeater, thus locking the channel from the previous memory cell. Something I forgot to mention before, and some of you may have been wondering why all these note blocks are here, is that you can actually remove a signal from the queue that's in the middle of the system. So starting with this first one, right? If I put the signal strengths 1, 2, 3, 4, and then 15 here, If I try to remove this signal using this note block, you'll see that this 15 and all the other signals that would be above it will come down by 1 to fill this empty cell. So if I click, you can see that the signal just moved down. I come over here, the same is true for this one. Same setup, just 1, 2, 3, 4, 15. See, once I clear it, watch that signal. See, that 15 just came down. Same for this last one, except instead of coming down, this guy, the signal is going to come up. So here's the 15 signal. Here's a lower, I think like 3 or something. So if I clear that, you should watch that 15. See, it comes up like so. Okay, so to build this first design, I'm going to come over here. And you can see here's the footprint that this first design will take up. I'm going to start off by placing these 6 blocks here. Oops, 6 blocks here. This is going to be the memory cell. I'm going to place a block in that corner and in that corner. Let's get rid of those blocks underneath, but you can leave them there if you want. Place a comparator facing that block, a comparator facing that block to dust. Make sure this comparator is in subtract mode. I'm going to start off by also creating another cell on top. You can actually, you probably should want to make your memory cells first before doing all of the side wiring, but I'll just do 2 for now, just to show you guys. Okay. So to create this blue line, which takes the signal strength and travels it down to the bottom, this memory cell, I'm going to place a block on the side of that dust comparator. So this comparator is reading from this block. We then power this block. We'll then power this dust. And is read by another comparator, which is set to subtract mode. All right, so I'll do that again. I'll make 2 more memory cells on top of this, just so you guys can see the pattern. So there's our memory cell, comparators, subtract mode, redstone dust, another memory cell, comparators, subtract mode, put some dust. Now for this blue line, see, so we already have this blue line coming out of here, so we need one coming from this guy feeding into this light green guy. So I'm going to use a different block just so you can see the difference. It's a block, comparator, like that, block like that, dust here, comparator here, subtract mode. And so you guys see it one more time. Subtract mode. That's kind of the pattern. Okay, so now for the reset line, we're going to come over to the side here. The side that has the subtract mode comparators. We're going to place 1 block on each of the memory cells, like that, and then 2 blocks on this cell, except we don't have one to place up here, so we're going to stop at this topmost one. Then on each of those comparators, we're going to pay for a repeater feeding to the side. We're going to put a dust on each of those, on this right side. And then we're going to put a torch tower going up like this. And I'll alternate the colors so you can see the difference, right? So it started with placing a block, this repeater being read in from a block, and then we put a torch and just alternate each side. One more block at the top. Okay, so almost done here. I'm going to place some blocks here like this, and I'm going to have a repeater feed into the start of this torch tower here. And I'll just place an observer with a note block for now, and then set this to 2 ticks. And there we go. And then we can just feed our signals into this top memory cell and we can read our signals out of this bottom memory cell. Moving on to the second one, come back here. You can see that this is the footprint of the second design, and I'm going to start off the same way. I'm going to place down the memory cell, place 2 blocks in the corners, place down comparators into those blocks, put this block on subtract mode, or this comparator on subtract mode, put down 2 dust, and I'll go do the same thing, place another memory cell on top, just so you can see how it all fits together a little easier. Comparator, subtract mode, dust, dust. Now for the transition line, do is we place a block on the side of that dust. We'll place a block over here. Comparator, and now this comparator is on subtract mode. It feeds into a block, to a dust. We can get rid of this block. And then it comes down, bends around like so. Okay, so one more time from the top. I'll build 2 more cells on top of what's already here. So memory cell, comparators, subtract mode, more comparator, subtract mode. Now for the blue line, I'm going to alternate the colors so you can see the difference between each line. Same thing. So place some blocks out and get rid of this one. Comparator subtract mode on this guy this time. Place a dust. Place another comparator. So, and then one more. So, comparator subtract mode into a block. And off the side of that block is a redstone dust. And we have another comparator. So, moving on to the reset line, we want to come to the side of the memory cell that has the comparator on subtract mode, and we want to place a block on the side like that, and just do that for every cell going up. I'm going to alternate the colors here so you can see the difference. On each of those blocks, we also want to place a dust. And this one we're going to leave alone because this is the dust that triggers when we clear the cell externally from either a pulse or some other system. We're going to come over here. This one's going to be orange because it's for this cell. I'm going to place a block on the side of that dust. Go up diagonally like that. I'm going to place a torch, and then another torch. Repeat this pattern going up. So this one is going to be red now because it's going to be for this cell. We just finished this one. So, oops. We want to make sure the dust here is actually in the cross mode so it can power this block. So block, and then go diagonally up to a block. So, and make sure you place these torches correctly. These torches aren't a torch tower just going up one after the other. It's an individual torch line that's just powering the dust that's right next to it. And then see this line is individual of this line below it, and so on, going up. We actually need one for this last one up here too. Like that. And like that. Okay, so come around to the other side. Now we're going to build the control line that keeps the 2 memory cells separate by disabling this comparator right here on this blue line. So we start off by placing a torch on this block. That's part of the memory cell. We'll place a block above that, and a torch on the side of that. And then that torch, if we place a block, this torch will then go into a repeater, into a dust, like so. And then we're going to repeat this line going all the way up, but I'm going to show you this way instead. Instead of building each one individually, we can just place a torch on each one. We can actually leave this top one alone. Do this one a different color. So block on top of that torch, torch on the side, place 2 blocks here, the repeater reading from the torch, and then a dust. One more time. So torch, block on top of that torch, torch on the side, blocks coming off, repeater, dust. Just like so. And lastly, I'm just going to put a repeater here, the observer, just to have a reset trigger. That on 2 ticks, and then just take our inputs and our outputs, like so. Please. Right, lastly, onto this final design. And back here, you can see here's the footprint of that design. So we're going to start off by making our memory cells. Now this one's a little involved, so I'll go a little slower. So we're going to place these 6 blocks. I'm going to place a target block on this bottom left and a normal block, normal block on the top left here. Get rid of those blocks. Now it's very important to make sure that these comparators go facing the right way. So this comparator has to face this direction, and this comparator faces this direction, so the signal will flow in a clockwise orientation. The comparator that's not reading or not next to the target block, we want this on subtract mode. Then we place some dust down, and for the cell above it, this, we want the target block now on the opposite side of where the original target block was. It's not modular going up, it alternates, right, the zigzagging. So this is now a block. And instead of, since this comparator is facing backwards, this comparator now will face forwards, and it's still on subtract mode. This one faces the other way, and then 2 dust. And I'll do 3 layers now, just because of how confusing it can be. So this one, it's like the same one as the first layer now. So this, like this, some dust, and there we go. Now I'm going to do something a little different compared to the first 2, and I'm actually going to replace in the reset lines first. So starting off, if we have this comparator pointing to the left, we want the reset line to point to the right. And this guy, comparator points to the right, the reset line goes to the left. So if this one faces left, we go to the right. And we just want to place a dust at the ends here, like that. And then a repeater, so it feeds into the side of the comparator. That. Alright, so come to the back here, and what we're going to do is we're going to place a dust on each of the non-target blocks of each memory cell. So right here, it's underneath the target block actually of the above cell. Alternate that going up. Oops. Leave that one blank for now, but we will want one there eventually. And then we place a slab on the side of the target block, like so. I'm going to leave this one blank because there's no cell below it, so we don't actually need a slab in this position like that. Place a dust on it. Same thing with this one, place a dust on it. Coming back around to the front here, the way we oriented this bottommost cell means that the transition line from this bottom cell into this cell above it has to come here to the right. So we're going to start off the dust we just placed before. We're going to place a block on the side of that. I'm going to place a slab down here. It's going to hold a comparator. Set this comparator to subtract mode. I'm going to place a block. So this comparator powers this block with a dust on top of that. And this dust feeds into a target block, and we want these guys to connect, is why this has to be a target block. Okay, and then into a comparator, into another block. Below this block, we then want to place a slab with a dust on it. You can stick a target block, off the side. Place 2 more slabs. Place a repeater coming off that target block, and a dust feeding into that comparator that's in subtract mode. So now we just finished the transition line that lets the signal travel from the bottommost cell up to the second cell. Now we want to do the same thing except on the left side, and this will let us send the signal from the second cell up to the third cell. Okay, so we start off again, same thing, the dust we had before. We're going to place a block, place a comparator this way, put it in subtract mode, feed into another block, into a dust, target block, another comparator, a block out of that comparator. Below this, we also want a slab with a dust on it, target block coming off of that dust, 2 more slabs, feeder off of this target block, and then a redstone dust, just like that. And here's a view from the back, just to make sure we have everything lined up, right? So we have some dust in these slabs, there's a dust inside there, dust on these slabs, and there's a dust inside there. Alright, so I'll build 3 more, just so you guys can see the pattern. So I'm going to start off by building 3 more memory cells. We alternate the target block. And we also alternate the comparator. So this comparator faces to the left, this comparator should face to the right on subtract mode. This one goes to the left. Place some dust. Okay. Cell above it. So this one went to the right, so this goes to the left. Subtract mode. Dust. Okay, and then one more. Alternate the target block. Alternate the comparator, so this one goes to the left, this next one goes to the right. Subtract mode. Place your other comparator, place the dust. Next, I'm going to place in the reset lines. So this guy goes off to the right. We alternate, go to the left. This guy goes to the right. This one goes to the left. Place our dust in. Feeder is going into the comparators to reset the memory cell. So we come to the back here, and remember that dust I broke before. Now I'm going to place it in. Place them all in, right? So they're not, it's opposite of the target block, right? So the regular block is where we want the dust. Then off the target blocks, we want to place in a slab with the dust on it, a slab with a dust on it, a slab with a dust on it. Now for the signal transition lines, we left off with this left one here. So we want to come up and place the right one that goes here. So we come around. Off of this dust, we place a block, place a slab with a comparator. Block, this comparator is on subtract mode. Dust is on that block. We place a target block, comparator, solid block. Below that solid block is a slab with a dust on it. Place another target block, 2 more slabs, and then a repeater and a dust. Okay. Now same thing, except it's mirrored and 1 layer up. So come around, place a block off that dust, place a comparator on subtract mode, place a solid block, place a dust on that solid block, target block, comparator, solid block. Below that solid block is a slab with a dust on it. Block off that dust. There's 2 more slabs. Repeater, dust. Okay, last one up here. So same thing. Solid block. Comparator. Solid block. Dust on top of that. Target block. Oh, this comparator has to be on subtract mode. This comparator into a solid block. Slab below that solid block. Dust. Block. 2 slabs. Repeater. And a dust. Okay. So I hope you guys see the pattern. We also want to make sure that this topmost repeater that resets this topmost memory cell is on 3 ticks, and we don't want to have a signal that's longer than 3 ticks, otherwise we'll erase more memory cells than we intend. Okay, and then I'm going to just place in an observer, a note block, just the trigger to reset, and we can just read out our signal strength from here, and we can input signal strength down here. And just to show you that these will work, I'm here back at the first one. I'll put something in, shift it down, something in, shift it down again. Again, you can see the signals we put in, so shift again. See the signals moving down. Okay, that was the first one. For the second one here, we don't need to shift, right? We just put the signal in and it'll just drop down to the next empty cell. Do it a little quickly here. Okay, so there it is. This one. And we can clear it. Okay. Now it's clear. This last one, similar thing, we have to put it in quickly. Check the cells, yeah. The rest of them are empty. This one, okay, it's stuck in the second one. This one, stuck in the third one, so on. We can keep clearing it. There we go. All right, that's all I have for you today. I hope you guys enjoyed. Take care.